Well, welcome everybody to another ACM seminar of general computing. My name is Mike Fong, and today's talk is presented by Sean Murphy, and the topic is selling analytics, getting people to use your model. A little bit about the ACM chapter. We were founded in 1957, so we're the most established professional organization. And our charter is to promote knowledge of modern computing. In addition, we support the community through networking, and we also have employers that will come and make presentations or actually make pitches for openings that they have. The way that we do our meetings, we try to have two per month. One is a general computing talk like this one, and held on the third Wednesday, usually. The second type of talk is our data science special interest group, where the topic is surrounding machine learning, big data, and so forth. We sometimes conduct meetings with other societies such as the IEEE, Valley, ML, AI, and others. We really encourage your support for our organization. This is how we are able to put on these type of events. So becoming a member or renewing is very simple. Just if you can, spend $20 for a year membership, please visit sfbayacm.org, and there you'll see a button to join. Wanted to bring to your attention 3 events that are coming up. 2 of them are the same conference, and it's on Friday, July 17th in the morning. The first one is called a Tech Talk Machine Learning in JavaScript by Jason Mays. He's a senior developer advocate for TensorFlow.js, Google. Jason combines his knowledge of technical and creative worlds to solve complex strategic technical challenges. Following that talk is one given by Rising Odugua, and the topic is build real-time image classifiers with TensorFlow.js. Mr. Odugua, a data science researcher at the Data Science Nigeria, and he speaks and teaches data science, AI, machine learning, and the future of technology via technical writings and direct mentorship. The third event, the week after that, is Monday, July 27th, and the topic is knowledge graph extraction from unstructured data and semantic role labeling. The instructor, we've had him as a guest before. He's really great. And his name is Robbie.
It's not Robbie. It's another speaker that's listed on the meetup site. There was a typo in the slides.
Oh, okay.
That got copied.
Greg, can you introduce that one?
Sure. So let's see. That speaker, let me pull up the page. Sorry about that. So I'm just switching over to the meetup page now. This is a person I met at the KDD Data Mining Conference last year. So it's Vivek Keta. He's an AI researcher at Accenture Labs in San Francisco. So that's the speaker for that Monday, the 27th.
Great, thank you, Greg.
Whoops. Let's see, where are we here? Right there. Okay.
Yeah, that's great. And so this is being viewed through Zoom and YouTube. And if anyone has any questions, you're probably used to it already, but you can, if the function is available, you can raise your hand to ask questions. And now we can introduce the speaker for this evening. Sean Murphy has worked in a variety of roles in the last 25 years. He's been software engineer, engineering manager, project manager, business development, product marketing, and customer support. Companies that he's worked directly with include Cisco Systems, 3Com, AMD, MMC Networks, and VLSI Technology. Sean's education is from Stanford University. He has a BS in mathematical science and a MS in management science. So welcome, Sean.
So
I think I need to turn this. Let's see.
you'll need to stop sharing.
Yep. And let's see, are you able to yeah, all right, good.
Well, thank you for that, Michael. The talk tonight is on selling analytics, getting people to use your models. I'm going to cover a couple of high-level points. The first is the definition of an analytic model for this talk, the need to understand the context for adoption and use, 3 common mistakes and 1 often overlooked opportunity that model developers make, and then some summary and conclusions. I will take questions as I go. Francis Adonza is going to act as the voice of the audience. So you're welcome to use the Q&A function to ask questions, and Francis will ask them of me as we go. Michael's already introduced me. I started out working in risk management at Anistics, doing analytical statistics. I've worked in semiconductors. I've worked in networking, and since 2003, I've been working with startups, helping them to generate leads and close deals. A lot of the folks we work with are doing some form of analytic model. So I'm going to leave it at that. Before we start, and this may save you an hour, I'm going to talk a little bit of what we're going to cover tonight and what we won't cover. So the focus is on how to get others to rely on your model to make decisions. We're going to talk about some common mistakes, examples and lessons learned. What we're not going to cover is a lot of interesting math that goes into these models, which turns out to have not very much to do with getting them adopted. And then the data wrangling and cleanup that's often required, which is at least half of the battle, but not directly related to getting them adopted. We will show the need for traceability, but I'm not going to go into the techniques that are involved in data cleaning.
Excuse me, Sean. Is this models in the sense of data science models?
Well, I'm going to give a definition of the model in a few minutes, and I think that may make it clear, but data science models will be part of that.
Okay, thanks.
But I'm going to talk about the problems of getting people to actually rely on data science models, not on the problems associated with developing them. So 4 key takeaways in terms of how to get folks to use your models. The first is the need to focus on critical business issues. The second is the need to provide actionable guidance. And you have to understand that different stakeholders can have very different perspectives, and you need to provide output that speaks to those different perspectives. Third, you need to offer explanations for the results and connect the results with the inputs. And finally, there are 3 broad contexts that models get deployed in. The first is in the form of alerts, the second is on demand, and the third is as part of a regularly scheduled report or dashboard that's reviewed, or a milestone report. We'll cover this in more detail. A couple questions to the audience, and you're welcome to type this into the chat if you like. What are people's roles? What's the background that people are bringing to this talk? Data scientist, consultant, data engineer, consultant. Oh, yeah, so CX, good. This is actually going to touch on CX. And I did a dry run with a CX expert on this as well, because a lot of that, we're going to touch on a number of CX aspects. Other folks? All the above. Okay. And then second question for the audience, as you're thinking about who will use your model, are you developing your model student? That's good. Are you developing models just for yourself, for peers in a work group or specific work group? Data scientist. Good. Department or function-wide, company-wide, dashboards for managers or executives, or for customer or partner use. When you think about the who's the audience for your models, or who's the target user set for your models, who are you trying to develop for? External Fortune 50 when companies are larger, good. Okay. Research. Okay. So to answer Bill's question, for tonight, I'm going to define an analytic model as an algorithm that provides a lens on the past to help you understand the present and predict the future. A good model enables you to anticipate events while there is still time to influence them. So another way to look at this is in the context of the OODA loop, or the observe, orient, decide, act. And so the model is often making separate observations that it then feeds into the orientation step. And in the orientation step, it may help to describe what happened, why it happened, likely outcomes or actions to consider, at which point a human decides, and then one or more humans act. So we're looking at man in the loop kind of problems where the model's providing input into the orientation step. Broadly, there are three contexts where an analytic model may get used. The first is as a continuous monitor or alert. The second is as a simple kind of assistant who's very diligent. And the third is on a schedule or milestone basis. That's typically more for a group or a team. So to get adoption of a continuous monitor or alert means that users agree to be interrupted and often woken up. So one example might be a smoke alarm that everybody can understand. Those of you that are in DevOps or website infrastructure may be used to getting alerts as part of chat ops or things like that, or a cloud infrastructure alarm. And that's one context. The second kind is where it means it's going to be used routinely as part of a task or for one person's job. And so here we're looking at a lint report that's finding some problems in a Android source code. The other is a Grammarly run, which is telling you might have some problems with a article that you're working on. So these are on demand as part of finishing a task. And then finally, there are the schedule or milestone based that are relied on by a group or a team. And here's kind of the status of a system deployment, looking at budget reports, sources and uses of funds, things like that. So adoption and rollout typically starts with a model developer and then working closely with a small group of people to help debug and refine it. Then it may go to a work group, it may go company-wide, it may go to executives. Ultimately, it may be deployed to customers, partners, suppliers. So three key mistakes that I've seen people make over the last 30 years, I guess, are that people spend a lot of time on problems that are mathematically interesting, but don't actually address a critical business issue. They provide results or an analysis, but they don't actually provide actionable guidance. And the third is they're unable to explain the connection between the results that they're offering and the inputs that they've worked from. And then there's a typical lost opportunity is that somebody does the analysis for their own purposes, but they don't think about turning that into a self-service model for others. So an example of a lack of a critical business issue, did some work with a startup a while ago that was doing research for the state of Alaska on network latency and the lag time in a wide area network. And we brought this back to Cisco, and they said, well, that's interesting, but the problem we're having right now is that people are pushing new configurations to the network and they're partitioning the network, or they're breaking off subnets so that the subnet can't get to the full network. And that actually causes a critical problem for us that looks like a system down or a production down, production stopped. And so it turned out that the team could solve that problem on the way to calculating the network latency. And there was some complexity associated with that, but they pivoted to focus on just the network outage, just helping with network plans before the configurations were pushed out. And ultimately were acquired by Cisco as part of their network management group. So they solved a simpler problem, which had substantially more value. So here are a couple tasks for whether or not you're working on a critical business issue. You're helping someone who's working on a task where to date there's unacceptable quality, cost, or error rates. Essentially, the work is unsatisfactory. You've been called in to help a project which is at risk of failing or where there's substantial cost or schedule overrun. You're working in a situation where your firm is not meeting customer commitments or their service level agreements are at risk, or a corporate goal or objective is at risk of failing. So one way to test for a critical business issue is that there's a clear cost or risk that the firm is willing to spend resources to fix or mitigate. Sometimes we fall into the trap of looking at nice to have or at things that would be interesting to explore, and it can often be hard to get resources or to get people's attention to actually deploy those kind of models, even if you get it working. So it's better to focus where there's near-term pain and it's a critical business issue. Second problem is the model doesn't provide actionable guidance. So we worked with a firm that was doing cell phone spend analysis where they were helping companies cut their cell phone expenses, and the bill would come in from the telco, and it would be a sorted list of phone numbers, and they would then take that and they would apply recommendations on a number by number basis. This phone is paying for a data plan, but there's been no data usage for the last 30 days. This phone is incurring roaming charges. There's no roaming plan in place. The minutes allocated here, you'd be better served to move to a higher capacity plan or a lower capacity plan. And as they started to work with their customers, the finance people that were interested in the cost savings said, in effect, what we really want is to be able to send a phone bill to each of the departmental managers, that if we could get this incorporated into the monthly expense review, then that gets the monkey off of our back, and it's also consumable in a way that the managers understand. So they went back and they added some fields that allowed them to encode the hierarchy of the customer organization, and then could present the bills rolled up at the manager level. So a lot of times, the way you're looking at the information may not be the way that you're actually going to get people to take action on it. So a couple things to think about. What are the underlying goals of the decision maker? What roles are they playing in that process? And what do the steps in that process look like? Where do you want to try and intercept that? Are there constraints on a model user taking action that you need to consider? We did some work with Flightcaster a while back that had a very accurate algorithm for forecasting if a flight was going to be late. The problem was the net effect of the application was to very accurately tell people an hour, 2 hours, 3 hours before the departure the plane was going to be late. But the airlines didn't recognize that they hadn't declared the plane was going to be late yet. So the user actually couldn't take any action with it. The other thing to bear in mind is if you're suggesting actions, do the cost of the actions you're suggesting, are they in line with the costs that they're likely to incur if they don't take action? So can you balance what the costs of failure are versus the cost of the changes you're suggesting? So Greg says, I call it begin with the end. How can you take action and who can make the decision? Right. So the real question is, who's the decision maker you're trying to serve? And one definition I like for decision is an irrevocable commitment of resource. So at what point who can actually sign off on making the decision? Who are you trying to serve? There may be recommenders, there may be other people involved in the loop, but ultimately you're trying to have an impact on a decision, which is an irrevocable commitment of resource.
Sean, there's another question. Someone asked, say I know it's a critical business issue. How do I know I have the right data points for my model? For example, having to cut budget and resources due to COVID, but not make any adjustments to shipping deadlines.
So that sounds like you're over constrained. It sounds like you're being asked to conjure savings out of thin air. Can you elaborate on the question a little bit?
Might have to come back to it. I'll wait for them to type.
So one question with regard to the COVID is, are there activities that the company is not engaged in that they might be no longer engaged in, they might be able to temporarily suspend or cut back on without loss of function, without having to lay people off? There may be things that they're paying for that they're not actually going to use. There may be space they're leasing, things like that. But I'm not getting enough of a context on the question to be able to help beyond that. All right. I did work with a team that was working on the data center infrastructure management, where they were helping design racks of equipment, design how to fit equipment into racks and to configure them. And what the pain point came when they were currently outsourcing the assembly to teams that were working out at warehouses that were essentially doing three-dimensional jigsaw puzzles. And the specifications were coming in as kind of Visio paper dolls. And without exception, there was one or more mistakes in the drawings, that the size of one or more components was wrong, one or more boxes was wrong, or they were specifying an AC box for a DC rack or a DC box for an AC rack. So we developed a database that said, here's 13 parameters for each box. Here's a way to take in that specification and check that things are going to fit and that those components belong together. And the first iteration of that would just come back and say, hey, there's an error in the rack. And what we learned was we actually had to add links to the data sheets to be able to say, according to the data sheet, this box is this wide, this deep, and takes this much power. Your drawing is incorrect for that reason. So that's an example of where you've got to get to ground truth at some level and be able to point back to the source for your information. A couple things you can do here are to document your descriptive analytics. So what did you do to clean the data up or make it useful? So as the user says, well, how did you arrive at that conclusion? The first thing you can explain is, how did you clean the data? The second is to enable drill downs in the output that tie to the original sources or the raw data. And the third, if you're also running diagnostics, explain what those diagnostics are and how they're generated. And all of this seems fairly obvious, but in fact, holds back a lot of stuff from getting used because it's obvious to the model developer, but it's not obvious to the person making the decision. Finally, a lost opportunity, which is that analysis was not converting to a model for others. So working in a company where we were getting ready to embedded systems design, and the latest version of the system software wouldn't fit into the EPROMs to be able to ship. And so we developed a compression algorithm, and we could boot compressed, and we made the schedule. Somebody did an analysis and said, okay, this has been going on for 4 years. If we look at that code growth, that should give us at least another 2 years before we exceed what the compression algorithm is going to give us. And then 4 months later, even compressed, the image wouldn't fit. And there were a couple of miscalculations. The first was that the code growth was a function of the number of developers, not just of the time or of the age of the module. That the more people you have adding to the code base, the more code that there is, and therefore the more memory it consumes. And so we had to go back and do a much more accurate model for that. The other thing we didn't do was to establish a guard band and actually monitor for every release how much spare memory or how much headroom we had, and to project based on the current growth what was going to happen. And so we actually got blindsided twice because we didn't create a regular report. And I think this happens more than you might like. That you do the analysis and you think, well, I'll never need that again because that problem's never going to happen again. So key takeaways for tonight: make sure you focus on a critical business issue, provide actionable guidance. Different stakeholders can have very different perspectives. Offer explanations that allow you to connect the results to the inputs and understand the context. Are you offering alerts? Are you trying to develop something which is going to be used on demand, or this is going to be used on a schedule, or as part of a milestone in a process? Happy to take questions on the talk. So question is business case. Could you elaborate on that? Yeah, I think when we talk about ROI to justify, that's what critical business issue actually implies. That you can tie this, that the company has got a clear cost or risk. So implicit in this is the ability to develop an ROI. And if you don't have that, then it's unlikely that your model is actually going to get used. So I think the question is, do you have a framework for the business case justification or spreadsheets? I think that very much depends upon the company you're working for and how they look at the problem. But typically, you've got to look for hard dollar cost savings or clearly identified risks that you're trying to mitigate. So you've got to have some before and after where you can point to, if we're able to spot this kind of problem. Francis, you still on?
Yeah, I'm just trying to go through these things. So here's a question. Do you work with explaining deep learning models such as object recognition or language processing? How do you describe those? Attention mechanisms?
You know, I think there's a lot of problems with that. And I think this is a sidebar I had that I took out, but explainability remains a significant problem for a lot of the machine learning models. And I think to a first approximation, business users are more comfortable living with problems they understand than with solutions that they don't. I think that's probably a substantial barrier to adoption for a lot of the machine learning stuff right now, is the explainability problem.
Another question is, can you share an experience where you used the OODA loop in a real world situation?
Yeah, you're all the time trying to figure out what's the deadlines you're working against. If you're in a competitive situation, how quickly is the people you're competing against likely to come back with something? And that's, you're often constrained by the need to respond effectively but quickly. So that's one of the things that drives the use of a lot of models, is to simplify the sense making problem so that you're able to respond much more quickly, because you can kind of pre-cook a lot of the calculations.
For business applications that do not yet use predictive models in a decision-making process, how do you go about helping your clients calculate the cost of integrating the models into the application?
Well, I think the question is, how accurate do you think the predictions can be, and what's the likely before and after of relying on the predictions or not? So I think it's a question of calculating a before and an after. Just to say, how often does the decision come up? What's the baseline threat or the baseline risk that you're trying to prevent? What's the relative frequency? What's the relative severity? And what's your ability to mitigate that? So you can get some idea of, are you focused on things that are high impact, high frequency first, and then working your way to low impact, low frequency.
Another question, what are your thoughts about the COVID-19 dashboard models, and how have they been used?
I don't think for the most part they've been used to drive decisions, unfortunately. I think a lot of them have been descriptive at best, and there's a lot of dirt in a lot of the data. So it's unfortunate. I think they've shed more. I think they're more used for advocacy than actually decision making, and for the most part. Were there particular COVID models that you found to be more useful?
Another question, while that person responds to your question, should there be a life cycle to models? What kind of maintenance monitoring do they need?
Well, there's always a risk that there's new events taking place you're not detecting, that there's been changes in the underlying situation that you're not monitoring for. So I think that it's the same with other software. You have to be careful that you're, especially if you look at alerts. Alerts have two kind of problems. The first is, as you pile more alerts into a situation, you pretty quickly have to develop a hierarchy and a filter on them, or you end up with what's happening in a lot of ICUs where there's just a welter. Each manufacturer's, sending off their alerts, and everything gets ignored. So I think that's one kind of layering that goes on. The other is situations change, and things that you were worried about a year or two ago may not recur anymore. There may be new events you should be looking for that you haven't yet included in what you're filtering for.
Okay. Here's a long one. Any specific experiences where data is siloed such that the data you need belongs to a different department than the one feeling the pain? To what extent do you have to walk the org structure on this? Do you have to present to multiple stakeholders and arbitrate their interaction?
Yeah, you do. And you have to tell each party what's in it for them. You've got to, for every cost that you're imposing, you've got to find a way to bring benefit to the other departments, or you've got to go up the chain to find a manager in common that's willing to say, yeah, this is part of my rice bowl. But when you're crossing organizational boundaries, the complexity on this problem goes way up. A lot of times you're better served to start small and solve small problems locally, and then glue those together once you've got some traction. But there's a lot of horse trading that has to go on, where you've got to make sure that to the extent that you're imposing cost on other organizations, you're finding ways to. So part of the other thing that goes on here is, we talked about supplier models, the suppliers giving you models. So if you look at things like design rule checks, or for 3D printers, manufacturability tests or testability tests, a lot of that is the downstream organization goes upstream and says, hey, if you'll run this while you're still working with the virtual representation, it'll save us the problem of finding problems in fabrication or finding problems on the customer site. So a lot of times it's often initiated by the downstream organization trying to save costs that both organizations have to share.
If you can frame it in such that the customer can see a benefit to caring about the air, that would help, but you may need to decide whether you want to have the customer's business, or do you care more about the air?
That's not a question. That was an answer to something that one of the participants asked, and I was just trying to answer him.
Oh, sorry, Bill. But more context around the original question. For business application does not yet use predictive models in the decision-making process. How do you go about helping your clients calculate the cost of integrating the models into the application? The follow-on context to that is, I was asking the question not about the actual prediction, but the cost of re-engineering the application and business processes and back office. For example, for counter fraud, when a transaction is pending, someone needs to review the result of predictions.
So the question, I guess the question I would start with was, who's bearing the current cost of failure? Who's bearing the current cost of fraud? And they're going to be the most motivated to encourage people or to pay for checks being instituted upstream in the process. Are you asking how to calculate the cost of writing the code, or the cost of getting people to adopt it?
We'll give it a moment, wait for him to
We'll give it a
reply.
moment. Yeah.
Bill, did I miss any questions?
Yeah, there's one here about a customer who's polluting the air and the groundwater. I guess it's cheaper to let them pollute. He's asking, what do you do when it's cheaper to let them pollute? I guess you have to figure out if that's in alignment with your own values.
And the follow-up to that previous question is basically the audience member was wanting to know, how do you calculate the ROI?
So the question is, when you look at what is your projection for the costs after, since you're talking about fraud, you're talking about losses. So what's the change in losses before and after versus the cost to get there? So how many, that can be calculated in terms of what's the ratio in a year, ratio in a quarter. Sometimes it's calculated as months of payback. How many months do you have to run at a lower loss rate to be able to justify the investment, right? And ordinarily, if you can pay for it in the quarter, it happens immediately. If you can pay for it in the year, it often happens. And if it's a 2 or 3 year payback, then it gets much more difficult.
So in regards to deployment and adoption costs, can Sean go over the main steps after you build the model? What does he typically cover in his contracts and what isn't? Ongoing support, retraining, debugging at an hourly rate?
So I would proceed in a more iterative fashion and try and build a very model and deploy that first and see if that has an impact. And then as you see what that does, you can then make refinements in it. So I think it's very hard to get it right the first time. Most of the time, you're seeing an iterative approach where you start with a small group, you start with people that are in the most pain, and you try and have some impact. You try and give them either more insights, you allow them to spot problems sooner, you give them better diagnostics, and you're then going to iterate on that. So then things fall through the cracks. So the question is, what's the residue? How do you attack the residue? And you may iterate 3 or 4 times. Often, cost is getting clean data. You may spend a lot of time getting clean data to be able to drive the decisions. So you want to start off with a very simple model that uses very few parameters, so that your data cleanup or data munging is as cheap as possible, or could be done as quickly as possible and as low cost as possible. In the case of the network, in case of the network planning tool, the disconnect, the router configuration language supported 900 commands. And so the first cut was, this was going to take a lot of effort to actually model all 900 commands and what they did. And so what the team did was they wrote a scanner, and they brought in real configuration files from running networks, and they just classified what commands were being given and what were the most common subcommands and parameters. And they discovered that 30 commands gave them about 90% coverage, that most of the commands were not being used most of the time. So that allowed them to say, okay, now we're going to focus on, these are the most commonly occurring situations. Let's make an impact there.
Someone asked about, in the low interest rate environment that we are currently in, do you think a 2 to 3 year payback is still going to be difficult?
It's the question is, who's the decision maker, and do they anticipate being in that role in 3 years? Because if you essentially incur expense for 2.5 years, and I don't anticipate being in the role for more than a year, I'm probably not going to pay for it. So it's as much got to do with management tenure as it does with interest rates.
Say you're asked to increase productivity in the manufacturing line, i.e. number of people it takes to process a pig or a chicken, but the model says to add more workers on the line at risk of COVID contraction to satisfy the demand. But the dilemma is that more workers will contract COVID, but the company objectives will be met. It probably is a question of when do a consultant's morals come into play.
Yeah, that doesn't strike me as a modeling question somehow. When I remember when I took decision analysis class a while ago now, Ron Howard gave an example of these beautiful brass valves that a German engineer developed that were actually deployed to vent the exhaust from a truck into the back of the truck to kill people they'd collected and put in the back of the truck. And his point was you should always pay attention to what purposes your engineering efforts are being deployed. And I think that's more of a values question than a modeling question. Seems like you're really posing a values problem, not a modeling problem. Also, I don't know that if somebody comes and says, I want a model that proves this, they're not actually, I think that's the problem. Somebody asked about the COVID models earlier. I think you have to be careful. If you're crossing over into advocacy, then that's okay. You should know that, but that's not really a search for the truth. That's the construction of compelling arguments, which is maybe a different talk. I'm assuming for the most part that the people that are paying you to develop models actually want to know the truth, and that your values more or less are in alignment with what they're trying to accomplish.
Here's one. What are some everyday models you apply for your own business?
Well, I think there's a whole bunch of rules of thumb. And in fact, so Gabriel Weinberg, who I'm a huge fan of, he's the guy behind DuckDuckGo. And I don't have the, he wrote a great Medium post a while ago about mental models that he relies on. He's got a list of about 100 that are actually quite good. And then he's got a book called Super Thinking, which kind of covers a whole bunch of common mental models that people use. I think the kind of things I use are amplify positive deviance, where you look for people that are outliers in a positive way, and you try and figure out what are they doing that could be more broadly adopted, right? I think you've got to look at the cost of gathering information versus the impact you're going to put it to. So the ROI. And I think the other one, which comes out of, which is, I can't think of the, it's, sorry, Charlie, sorry, so the circle of Charlie Munger, the circle of competence model. You're better served to focus in a narrow area where you've got extreme competence than to scatter yourself in a lot of directions. So I don't know if those are exactly the models you're looking for, but those are a couple of models that I use, at least in my work. We focus primarily on the how to help teams of engineers and scientists find early adopters for very complex products. So it's, how do you stand on the customer's shoes? How do you look at the problem from their point of view? You know, how do you walk around the situation, see it from a variety of perspectives? Well, I'm happy to take any more questions, but it looks like folks have pretty much asked what they wanted. I want to thank the SFBA ACM for the opportunity to present tonight. And I will turn it back over to Michael Fong, I guess.
Hello, thank you. This is Liana Ye. Now, thanks, Sean, and nice discussion here. We'll see you later. And thank you very much. Thank you for all these participants. Have good questions and discussions.
I got one question about the slides. If folks want to email me, I'm happy to send them a copy of the slides.
Sometimes we tell speakers if you can just print a PDF and attach it at the bottom of the meetup page for the event, there's usually a discussion section. So if you just post it there, then people can find it after the fact.
Okay.
But I'm happy to have them, have you respond. But that's
No, I can definitely make a PDF and post them.
Okay.
Okay, I guess that's we've come to the end. Thank you very much, Sean. And I guess I'll end the meeting here. Thank you.
Thank you.